Energy is the basic requirement for the performance of all activities. The existence of the living world depends upon the flow of energy and circulation of materials through the ecosystem. The ultimate source of energy for all ecosystems is sunlight. Energy entering ecosystems as sunlight is transformed by producers into chemical energy through photosynthesis. That energy then passes from organism to organism in the food web. Energy and inorganic nutrients flow through the ecosystem. Energy flows through the ecosystem in the form of carbon-carbon bonds. When respiration occurs, the carbon-carbon bonds are broken and the carbon is combined with oxygen to form carbon dioxide. This process releases the energy, which is either used by the organism to move its muscles, digest food, excrete wastes, think, and so on, or the energy may be lost as heat. Energy does not recycle. The energy is transformed from one form to another. Thus, the total amount of energy in this universe remains the same. The autotrophs obtain these inorganic nutrients from the soil or water surrounding the plants or algae. These inorganic nutrients are passed from organism to organism as one organism is consumed by another. Ultimately, all organisms die and change into detritus. The detritus is the food for the decomposers. The remaining energy from detritus is extracted and the inorganic nutrients are returned to the soil or water, which are again taken up by producers. Thus, the flow of material is cyclic, while the flow of energy is non-cyclic. The food chain is a series of living things which are linked to each other because each thing feeds on the one next to it. A food chain comprises a sequence of organisms through which energy and nutrients are taken in and used up. Simply, a food chain is defined as a process of eating and being eaten. An example of a simple food chain in a terrestrial and marine ecosystem could be grass, which is eaten by a grasshopper, and the grasshopper is eaten by a rat, and the rat is eaten by a snake, and the snake is eaten by an eagle. Another example is algae, which is eaten by zooplankton, and the zooplankton are eaten by small fish, and the small fish are eaten by large fish, and the large fish are eaten by whales. Trophic levels, derived from the Greek word trophy meaning food, represent the major feeding levels within an ecosystem. Food chains begin from producers to consumers, and these levels are what we call trophic levels. There are several trophic levels. First trophic level. Producers belong to the first trophic level, such as plants and algae. They prepare their own food and are therefore called autotrophs. Second trophic level. Organisms that feed on living or dead producers belong to the second trophic level. Examples include cows, goats, deer, and grasshoppers. Third trophic level. These organisms feed on secondary consumers and belong to the third trophic level. Examples include owls, bluebirds, many snakes, and fishes. Fourth trophic level. Carnivores that eat other carnivores belong to the fourth trophic level. For instance, an owl may be hunted by an eagle or a hawk. Food webs consist of all the food chains within a single ecosystem. They indicate the feeding relationships among species in an ecological community, essentially showing who eats whom. Typically, species are connected by lines or arrows, which are called links. Biomass is the total mass of all living things within a specific area. It's a representation of the amount of energy contained in biomass at different trophic levels for a given point in time. The amount of energy available to one trophic level is limited by the amount stored by the level below. Because energy is lost during transfer from one level to the next, there is successively less total energy as you move up trophic levels. The mass of producers is greater than that of herbivores, the mass of all herbivores is greater than that of carnivores, and the mass of carnivores is greater than top carnivores. If we construct a three-dimensional graph of biomass in successive trophic levels, it will resemble a pyramid. This is called the pyramid of biomass. The pyramid of numbers is the graphic representation of the number of individuals per unit area at various trophic levels. Usually, producers are greater in number, and secondary consumers are the least in number. If we construct a three-dimensional graph of the number of organisms in each trophic level, we will get a pyramid of numbers. For example, the number of herbivores like zebras and cows is more than that of carnivores like lions.